to this tutorial. Today we're going to just talk about algebra. This is a tutorial following up what we've learnt in class over the last couple of weeks, so we're going to start from the basic system. Okay, so let's just ask you guys a question. What is algebra? So what does algebra mean to you? Can you define it?
That's a real philosophical question there, really.
Okay, so in a mathematical terms, you've got several types of mathematics. Arithmetic is basically adding up, multiplication, and division. Calculus goes on to integration and differentiation. And then we've got algebra. So
it's rearranging formulas with x and y into other formulas.
yeah. Basically, that's the essence of what algebra is. It's substituting numbers for letters. Sometimes this makes it easier to rearrange an equation. If we can substitute a complicated expression for an x or a y, an a or a b, it becomes a lot easier to mentally move it around. Okay. And an important thing about algebra is you have to think of it like a set of scales. So if you have an equation, just an a equals x, simple equation, if you add something to one side of the equation, you also have to add it to the other side of the equation. So the equation, like a set of scales, has to balance. Okay, the first thing we're going to go through, got that sorted, is the rules of indices. Now, does everyone know what an indice is? Okay, an indice is when you have an expression to the power of something. So x to the power of 4 is the same as saying x times x times x times x. Okay, do you understand that? And do you understand how the nomenclature works? Okay, good. So, now with rules of indices, it's basically about what happens if we have an expression with an indice and another expression with an indice, how we combine them to form one expression, or a more simplified expression. So, if you grab your piece of paper, yeah, thank you, Stuart, and we'll write down the first one. So, if we have a to the power of n multiplied by a to the power of m, can we write that as a simple a to the power of something?
A to the power of m times n.
Okay, that's a common mistake. No, it's good to bring it out. It is a common mistake because you see a multiplication there. I think it's a multiplication there.
Oh, so is it n plus m?
Yes, exactly.
Brilliant. I didn't see that from you, honestly.
Well done, Stuart. So, n plus m. Okay, right, the second one, following on from that, we've done a multiplication. So let's do a division. A to the power of n divided by a to the power of m. So based on what we've seen from the first one,
a to the n minus m.
Yes, exactly.
What happens if n and m are the same?
If they're the same, well then, in the case of when it's minus, it will become a to the power of 0. And this, it's a good thing you bring it on. A to the power of 0 is a special case. Is there any idea what a to the power of 0 would be? Rachel?
Is it 0?
It's not 0, I'm afraid. Yes, excellent. It equals 1.
Why?
It's a special case, and when you have anything to the power of 0, it's just equals 1. If you want a full definition, I can give you a better definition in our next tutorial. Okay?
Great, thank you.
You're welcome. So, we'll move on from this, and now let's have an, so a to the power of n, and then that whole expression to the power of m. Can you continue writing this down? So, how do you think that would go down into one expression? If a times a to the n times a to the m equals a to the n plus m, we've now got a to the power of n to the power of m. So that's the same as saying 2 squared squared. And 2 squared, so 2 squared is, okay, and then it's saying 4 squared.
16.
Yeah. So is there a way we can get 2 to the power of 1 unit that equals 16?
That's 2 to the power of 4, isn't it?
Yeah, that's 2 to the power of 4.
So is that 2 times 2? So it would be n times m, a to the power of n times m.
Yeah, exactly. So let's write that down.
Oh yeah.
Does that make sense? Do you see how to get that? And does the numerical example help?
Yes.
Excellent. So that's an example of how we can use numbers to check our theory and where our theory comes from. Okay, so we've got 4 rules down at the moment. Now, if we had a to the power of negative n, when you have a negative power, it can become quite complicated. You look at it and you think, okay, I've got a to the power of negative 2. It, visually, kind of mentally, it becomes quite difficult to do. So is there a way we can make this equation easier to understand? So, what would make that easier? So, if...
Can you times it all by a minus 1?
And what would that achieve?
Then you could get minus a to the n.
No, you can't do that, I'm afraid.
Why not? How do you do it then?
Okay, well, I'll say. It's a basic... This is another law. These are all rules of indices, so they're the basic things that we need to know.
Can you can you times it by a to the n?
You could do, but that's a more complicated version. As this is a basic rule, I'll just tell it to you.
Okay.
It becomes 1 over a to the n.
Oh, right, okay.
Okay. And then we've obviously then got a to the n, which is quite an easy thing to do. And then it's just taken as a fraction. So there are 5 of our rules. We've got a couple more to go through. A to the power of 1 over n. Now this is written more commonly as something else. And it is the root back from where you square something. So normally if you square thing, you then take the square root of it. So this is the visual representation of what the square root is. So that becomes, and is the same as a to the root n.
So is square root a special case of that when n equals 2? So is square root a special case when...
Square root is a special case of that when n equals 2. So if you just see root, that is the square root. So that's the same as having a 2 there. It's just a special case where in most mathematical terms that's the same.
See?
No, I don't get that. So this, that without anything there is a square root of a.
Yeah.
And this is what? Square root of a.
So, yeah. So if we had a to the third, it's the same as
The third root of a.
Cube.
Yeah.
Is that the cubed root?
that's the cubed root.
Does that appear on your calculator?
It does appear on your calculator, and on your calculator there's a button. It depends on the type of calculator you have. Normally it would be a second function button, but you can go down the powers as much as you want. There is a button that represents this on your calculator. You aware of this button? Oh, I don't have a calculator on me, so I can't show you, I'm afraid.
No, what? That's nothing. That doesn't look like that.
It doesn't look like it, but what this represents is there, it represents that it's up, so it's to the power, so it's superscript on your calculator. So you can do your number, or A, and then you press this button, and to put in a fraction, you'll have an A over B C button on your calculator. And then you can enter this section as that. Okay. Right, so in front of you, you now have these rules. These are the basic rules of indices. So, do you guys have a basic understanding of algebra and how you can use these rules? And all these rules apply to more complicated mathematical equations, and they're really important to learn. So as a consolidation exercise, I want you to go home and learn these rules. And there are some examples here in your handout, and just work through a few of these examples to make sure that you understand how you can manipulate them, and then come to the next tutorial with any questions or problems that you may have. Okay.